Okay, hello, and I will show you in JASP how to operate with the JAGS module. So this is JASP and already opened. You just need to go to the JASP website and download the last version and install it in your equipment. And so I will open the data set that is included in this tutorial. So let's go to open, computer, let's go to our folder, and then this is our data set. As you can see here, we have several variables. We have age and age squared, as it was in the tutorial. And now we will click on the JAGS module. So if it's not visible, you just need to click on this, and this will open up, and we'll just need to use this, the JAGS module, to be visible. Okay, let's click on the JAGS, and now we need to specify the model with some syntax that I will have here. Is the syntax that is present in the model, in the website, and also in the slides. Okay, so Control and Enter to apply it, and now the module is prepared to show some results. I will show you the beta 2 parameter here. And now we have the posterior mean, median, and standard deviation, the credible interval, the R hat statistic, as you can see here, is 1.0. That's very good. And remember that the criterion was 1.1, and we have an effective sample size of 5,000. Okay, so we have that output based in 6,000 MCMC draws, and it shows here the same, the R hat statistic. That is, remember, that is the potential scale reduction factor. Okay, so here are several options. If we go to plots, you can see here that we can show the density plot of all of the chains. We need to aggregate the chains, or maybe we can disaggregate the chains. As you can see here, the density plots are very similar. If we show the trace plot, here's our trace plot. So let's make it horizontal to see the caterpillar form. As you can see here, is very stable. Now we can use the autocorrelation plot that is here. We can use it as a line or as a bar. As you can see here, everything is below 1.1. We can use it as bars if we needed to. And also we can use scatter plots if we need to, but this is not necessary. Okay, we can also show histograms of the chains if we want to, but I think density plots is more intuitive. So we have a density plot, trace plots, potential scale reduction factor, autocorrelation plots. So everything seems okay. We can also show other color palettes if that's not okay with us. For example, here you can see more brighter colors, or maybe you can just use shades of blue, as you can see here. So everything seems to be okay. I will switch to the colorblind just to ensure everyone is seeing this correctly. Okay, so now we can show more options. For example, like customizable options of what you want to estimate. We can specify the initial values for each of the parameters. For example, for beta squared to be a specific value or something like that. So, and finally, in advance, we can specify things for our MCMC. For example, we can use more iterations. For example, instead of 2,000, we can use 3,000. And we can use, instead of 500, we can put 1,000 burn-in iterations. Let's put, for example, a thinning of 2 and 3 chains. We can set the seed, for example, for 1, 2, 3 to ensure replication or reproducibility. And we can use some deviance statistics here. So as you can see here, it's pretty simple to make this MCMC to work. I will switch this off. I will now increase into 4 chains, for example. And now, as you can see here, we have 4 chains with our own density, so everything is going good. So I think that it seems that this MCMC estimation is stable and representative and precise, and also is efficient. As you can see here, it takes barely a second to estimate it. If we want more complicated models, then we should aim for something more complicated, for example, than a simple nonlinear regression. Okay, so that's a quick tutorial on JAGS. Thank you very much.